Welcome to how to use the laser cutter. I'm sorry, this will be a terrible lesson, but you should come away knowing roughly what you need to know. The first thing is we've got a materials list here. There's a few at the top that you do not want to cut. Outside of that, you can experiment around, try some things. But first one, PVC, do not laser. It makes chlorine gas. That's bad for people. Same thing with vinyl. So it may be thin, but it burns, and then you get chlorine gas in your lungs, and everybody gets lawsuit happy. We don't want any of that. Polycarbonate or Lexan, like glasses, lenses, you can't laser. If you have a mysterious plastic with film on it, you don't know what it is. If it doesn't say acrylic somewhere, it might be Lexan. If you're not sure, probably don't want to cut it. Most of the stuff we have floating around here is acrylic and says so on the paper. You don't cut metal with this laser. It's too reflective and we don't have enough power to cut through it, so you're just going to damage the lenses and mirrors and break the laser. Carbon fiber doesn't cut. It's just too dense. The laser won't get through it. You can waste a bunch of time or give up ahead, and yay. Fiberglass and PCBs are another thing. It just won't cut through it. The glass will etch, but it won't cut. And then anything reflective you don't want to cut for the same reason as metal, because it can damage the mirrors and the laser, and those are expensive. And if you don't know what something is, you probably don't want to cut it. Like I mentioned before, if you just find a random piece of clear plastic around, it could be Lexan, it could be acrylic. If you're not sure, don't cut it. As far as things we can cut, you've got acrylic, Delrin, polyethylene film, mylar, polyurethane, HDPE, like milk cartons, plywood, solid woods, depending on how dense they are. They may cut, they may just etch. You'll have to experiment a little. MDF and particle board will cut, hardboard will cut. Let's see, cardboard, cardstock, paper cuts, rubber cuts. Silicone you can cut, polyester you can cut, nylon you can cut, denim you can cut, leather, cotton, marble, leather and cotton you can cut. When you get to marble, granite, and stone, you might be able to etch lightly on the surface, but you're never going to get all the way through it. Ceramics, same thing. Glass, like I said earlier, glass that's not tempered, you can etch. If it's tempered, you're not going to touch it. So that's the general list of known substances that work. It's posted here on the wall for anyone who needs a reference.
If it's on that list, how thick a piece can fit in there?
Well,
If
thickness.
someone's just talking about etching,
Yeah. Thickness. It's basically if you can fit it in there, and the lens will move up. I'll talk more about adjusting the cutting height later. But if it fits, you can try to etch it. Where are we going here? So, as far as what to check to make sure before you start cutting, there are 3 switches on the front and a big red switch on the laser itself. So to turn it on, you just disengage the emergency switch on the top. It'll say booting up, give you an IP address, and then at that point there's a little home button that says AF underneath it. You press that and the laser will return to its home. If you want, you can zoom in. So, here, I'll start over and show you with hand motions, I guess, or can you see everything? Anyway, to turn on, rotate the emergency switch, it says booting up, gives you an IP address, and then you hit this little home AF button, and it will home itself. So that's the first thing you do. The next thing you want to do is turn on the water, make sure the pump is running, and that you can see water coming back into the bucket. Got to make sure it's cycling. If you turn it on and you don't have return water, you'll run out of the bucket sooner or later, and who knows where the water went. The next one to turn on is the air switch. That'll make this horrible humming noise. If you reach under the laser where the red light is, you can feel the air moving. And the third one to turn on is the fan switch. That's the big green fan in the back. If you put your hand on the bed here, you can feel it sucking the air down. It also sucks the lid shut. So whenever you're running an actual cut on the laser, make sure you've got water, air, and fan, and that you're homed. Those are the big 3 initial checklist items. So in the meantime, I'll turn off all the noise while I keep talking to you. Once you verify that your pump's working, you've got water, air, and fan. Let's see. You would take the material you want to cut and shove it in the laser. So I'm just going to use... Oh, I'm just grabbing a random scrap. In theory, it's stuck on a battery. Here we go. So this is just a scrap of 1/4" acrylic. And you can see here it says acrylic sheet on the paper, so you know what you've got. When you cut with the laser, you always want to start in this top left corner, which is very annoying because it homes to the top right corner. So you set your material there, and then on the front of the laser there are these 4 arrows, and you'll see here in the corner it says FX. That means fast XY movement. If you push the button, it will move quickly from one side to the next. So you want to set the laser roughly at the top left corner. You'll see it's hard to get it exact when it's on FX. There's an F/S Z button. If you press that, it'll switch to slow XY. If you accidentally press it twice, it goes through a bunch of other settings. The only ones you want to deal with is fast XY, which is what we started on, and slow XY for fine-tuning and getting the laser right where you want it. You typically want the laser to be, again, in the top left corner of whatever material you're cutting. Once your material's in place and you've got the laser in the top left corner, there's a spacer here. It's magneted to the top of the machine. Always leave it there when you're done. You want to place that on top of your material, and then there's a little screw adjust here. You don't need to crank it down a lot. You just lightly loosen it. It'll let you slide the lens up and down. Adjust it so it's sitting on the spacer, and then just gently finger tighten it enough that it won't move, but not so much that you strip any screws. And then you want to be this distance. It's 1 inch above your cutting surface. So right now you can see laser in the top left corner, correct distance above the cutting surface. I mean, if you're off by 1/4 inch in either direction, it's not the end of the world. And yeah, top left. So once you've done all that and your water, air, and fan are on, you're ready to move on to computerly things. So where am I? Fast XY, slow XY, adjust the cutting head. Oh, one thing to do when you start using the laser is just look at the mirror in here. Let's see. So that, if you can see that it's kind of gray with smoke or something, it's pretty clean right now. We have these Kimtech screen wipes.
You're talking on top of the red thing.
Yeah, on top of the red thing. That's the only mirror that's really going to get dirty enough that most users will see it. We've got special lens cleaner and these lint-free wipes to clean that with. Just gently wipe it with your finger if it looks dusty. For the most part, it stays fairly clean on its own, but if you've been cutting a lot of wood or something, there may have been some smoke that got on there. It's a good idea to wipe it off. Am I missing anything in Physical Town? Nope. Oh, one last thing. Sorry. Pick the camera up again. This magnet here is a sensor. If you leave the lid open, the laser will not fire. It'll keep moving like it is. If at any point you open the lid during cutting, it shuts off the IR laser. The red laser is just a viewfinder, so you can see where it's going to cut. It's not the actual laser that does the cutting. So unless the lid is closed and this magnet is here, the laser will not work. And that's good for your eyeballs. Most eyeballs don't like high-powered IR light. So let's see. Yeah, so so that's the physical setup on the laser. The next step is a program. So you've got the laptop here. When you get to it, it will be locked. Don't tell them yet.
Don't tell the password on the video.
There's a secret password that you will learn after you have watched this video. When you log in, you'll find there's a program called Retina Engrave 3D. It's also pinned to your taskbar. That is the program that it's basically the laser's print driver. So you open that program up, it'll say it's initiating connection down here. You should see connected to the IP address you saw on the laser earlier, and it'll say homed. If, for instance, I shut it down and hit refresh, it will say, oh no, I can't connect. It'll turn red. Yeah, there you go. So it's searching the network because I just shut off the laser, and it's unable to establish a connection. If you turn the laser on, hit refresh again, it should find it. Let's see. There you go. So now it's connected and it says not homed. If you ever get the not homed error, just press the home button on the laser, or you can press the home button in Retina Engrave up here at the top of the screen. And again, that will home the laser all the way back to the top right, and then you manually have to move it back to the top left of your material before you do any cutting. So I will once again move it all the way back to top left now. Be careful when you get towards the edges. You want to go into slow mode so you don't crash the laser. You don't have much margin in the top left corner, so take it slow when you get near the edge. Alright, so we're connected, we're homed. That's the first battle. Let's see. Verify connection. So now you're ready to cut something. I will, let's see, pull. I think we put random things on here. If not, I'll get a thumb drive out. What's on my desktop? Laser. Oh, that's my user folder. Alright, I'll get a thumb drive out. There's some kind of USB port on the side of this computer. I make no claims about virus safety. And now we wait for Windows to find my thumb drive. In theory. You don't do any editing on these, do you?
I don't want to.
Alright, so... Oh, and I don't even have files on here anymore. Well, damn. I'll go to Design View. Typically, you would have a PDF that you want to print. So, I guess I can go find something online. I don't know. Oh, well.
Good example, do it.
Okay. What do we got?
So the laser cutter wants it in a PDF format?
Well, the easiest way is to have a PDF that's already scaled to size and then print to Retina Engrave.
And it converts it?
Yeah, so that's fine. What's a good thing to find a PDF of for this tutorial video?
Flowers? I don't know.
Somebody had the...
Spade, like all cards or something.
Do we have the logo somewhere?
No.
Okay. Someone had it open before.
Here's that one.
That looks pleasant. Okay. I will Anyway, can I just print a PDF from here? So I will save as a PDF. No, that's going to be a pain because it'll still have all the header. Oh, there we go. Yay! I'll throw that on the desktop. Alright, so now we have a PDF on the desktop. I apologize for not preparing beforehand. So it shows the 801 Labs logo. You'll note that this is just a raster image. It's made of pixels. It doesn't have any vector information. If you print a PDF directly from a program with vector information, the laser cutter will take that vector information. So for now, I will go to File Print, and then on here you'll find there is a full spectrum engineering driver. You want to print with no scaling. That's important. If you've already got the PDF set to a scale, you don't want it to rescale it to something else. Then you hit OK, and it will open in whatever this thing's called, Retina Engrave. If Retina Engrave isn't open when you print, you'll get an error. So make sure Retina Engrave is already open when you print your PDF. Now what happened is on the Raster Engrave tab, it found that image in the PDF and cropped it down to that size. So what happens with the raster is that's when you want to etch something. It'll take any image, picture, what have you, and it'll zoom back and forth across it, blackening or whitening. So over here on the side there's a black and white threshold. If you keep lowering that, you see how parts of the logo are disappearing. Since this one's already pretty much all black and white, it doesn't do much. But if you have a picture with a lot of grayscale, you can control at what point it decides to cut or not cut. So this is basically adjusting what your raster will look like. You'll also notice there's a raster power setting and a raster speed setting. I'll go into more about what power and speed settings to use for what materials and what purposes later. You'll also see there's a vector cut tab. On this one, the vector is only a rectangle around the image I found online. If you had a real, whatchamacallit, vector file in your PDF initially, this would show up as a vector file. I'm going to go over here to Design View. I typically almost never use this, but it's convenient for giving me a vector I can play with. So I'm just making a little slightly less than half-inch square, and then I click the Render button, which will output my half-inch square to the Vector tab and the Raster tab. So, yep, and that just, it loads whatever you most recently printed or rendered from Design View into Raster and Vector tabs. So it doesn't really save your progress or settings. You've got to start over on every cut. You'll notice under Vector Cut it has a color setting here. If you've got multiple layers in your vector file, you may end up with different colors. You can also change the color of an object manually. So you can have different settings and cut at different speeds and powers for different objects. So if I went into Design View and added a second rectangle next to the first and then rendered it, here we go. Now there are two rectangles. I can make one of them red and the other one black and set different vector speeds and powers. With raster, you only get the one power and speed setting. So now we've got a vector file that we want to cut out.
So what's the difference between raster and vector?
Oh, vector will trace the lines only that it's given from your file. Raster goes back and forth across the image over and over again, only marking where you've set your black and white threshold to black. So if it shows up black on here, the laser will fire. If it shows up white, the laser will do nothing.
So if you want to outline something, use the vector. If
Yeah,
you want to
if you
draw
wanna-
something, use the raster.
If you want to cut out a shape, you want to use vector. If you want to
Darken
like-
the whole area.
make a portrait of somebody or take a picture online and etch it into something, you want to use raster.
Yeah.
Okay, let's see. So, I'll come back to the new materials testing. You'll find that in the middle of the paper on the desk. But right now I have a known material. If you look over on the laser, there's a clipboard where people write down what they cut, how many minutes of cutting it took, thickness, and what settings they used as far as speed and power. So if they were cutting or rastering, they'll write different settings depending on what they did. Since we know we have 1/8 inch acrylic, the typical speed and power settings for that are 17/100. So you come over here. I'm just going to do a vector cut first. We'll come back to raster later. So for the vector cut, I've got my speed is down to 17 and my power is at 100. I'm going to do the other one, the black one, at a faster speed and 100% power so you can see the difference. Basically, if you're at 1% power and 100% speed, that's the least energy you can be using with the laser. As you increase the power and keep the speed at 100, that's going to add more energy, and then if you slow down the speed once you're at 100% power, that will continue to add more energy per distance to the material. The more energy you add, the more likely you are to cut through something. Some materials, like a piece of normal paper, you can probably run at very low power and high speed and it'll cut through it just fine. Other materials like clear acrylic, there's not a lot of IR reflectivity for the laser to hit, so you need more power and less speed to get all the way through it. So I know at 17% speed and 100% power, you're almost always going to cut all the way through 1/8 inch acrylic, and I know at 50% speed and 100% power, you're not going to make it all the way through. So now I'll go over the steps you need to follow right before you cut. The first is what I started the lesson with. Make sure your water is on and you can see it in the bucket. Make sure the air is on and you can feel it coming out of the laser. And make sure your fan is on and you can feel the suction. Once you have all three of those on and you've got your vector settings and you're using speed and power that's reasonable for your material, there's a button up here that says Run Job Perimeter. You can also use just the J key to activate it. When you hit that button, the laser will start at the top left and draw an outline in real life of your material. So it'll show you exactly how far it's going to cut. And as you can see, the laser stays on the material the entire time. If, for instance, I was over here, off the material, you can see that the laser moves off the edge of the material. You just need to adjust using the arrows until your entire job is on your material. That's very important because if you're just lasering into the bottom of the box, it's going to damage the laser cutter and nobody wants that. Once that's all done, you've made sure your water, air, and fan are working. All you have to do is press this play button here for start job. You can also hit the G key. Again, confirm that you're using a reasonable speed and power for all of your vector colors. I'm just using vector mode. You can also just use raster mode, or you can raster and vector at the same time. There's also an option to simulate vector. which will basically move the cutting head without actually cutting. If you don't trust that the job perimeter gives you enough information, you can watch the cut as it goes through your entire operation to make sure it's working. So I will stay with just vector mode. The DPI, if you have a very fine item, you can increase it to 1,000. If you've got basic simple shapes like I do, you can lower it to 250 by 250. So again, the fan's on, the water's on, the air's on, reasonable settings. I've checked the job perimeter. Now I can hit go, and it should cut 2 squares out. You'll see there's a white light and occasional little flames. Occasional flames are fine. If you've got lingering continuous flames, you're going to want to hit the emergency stop button. As you can see, it got through those 2 cuts and dinged. That means the cut is finished. I can now open the lid and pick this up. So what you'll see is that the red square on the right that I had set to 17-100 cut all the way through, whereas the black square that I had set to 50-100 didn't make it all the way to the back. So whenever you're using new materials or something unknown, you basically start at very low power and high speed and do a bunch of test cuts, slowly increasing the power until you get to 100 and then slowly lowering the speed until you get through it. Some materials like plywood, you may want to do multiple passes at a higher speed instead of trying to do one pass at a very slow speed. I'll turn off the noise. What was I saying? Yeah, multiple passes at a higher speed may work better in some materials like plywood than one pass at a lower speed. And when you're done, I mean, that's all there is to vector. I can do a quick raster of the 801 Labs logo again to show you how that process will work. And yeah, so I'll reset up the material now. Since I've already cut it, I don't want to start at the same point, so I just move somewhere else on the material. Let's see, that's too fast, so I'll slow it down. So now that's the top left of my cutting area, instead of being over where I already cut. So let me reload the 801 Labs logo by again printing to the full spectrum engineering driver at no change in scale. Here, move this over, sorry. Okay, so I printed. It's now appeared back here in the raster cut. I'll set my black and white threshold down somewhere in the middle, 120-ish, so you can see some definition around here. And now I'll hit the run perimeter button. Oh, I'll close the lid first. So this will be running the job perimeter in a second. Oh, actually, hooray, the error came up. This is secretly what I wanted. So what this error says is that the laser does not have enough space to complete this action. So raster jobs require lead in and lead out of 0.8 inches. So what it's telling me is I'm too close to that left edge to do a raster here. When you're doing a vector, you can go right up to the edge of the cutting area. With the raster, the laser will skip past the cutting area and have time to slow down and speed back up, so you get very consistent speed through the cut. So all that means is that I have to hit, no, I do not want to accept risk of damage and continue, and then move the laser over to the right to get me out of that danger zone. Now I will once again check the job perimeter. So, here.
Too big.
Yep. Sorry. So let's do that again. Job perimeter. Come on. You'll see that it's going off where I have material to cut, which is telling me that my 801 Labs is too large. So, to fix that, I can go back to the printing and adjust my scale there. So I will say custom scale of 50%, or 800 if numlock is off. So now it will once again reload in here, and you'll see that it's gotten much smaller. So again, I'll check my job perimeter and see that the entire raster area is directly on the acrylic. And I didn't get the warning saying I was too close to the edge, so that means I'll be good to raster. Right now I've got the speed set to 50 and 100% power. That's fairly typical for etching acrylic. If you're etching something like glass, you may want the speed even lower. If you're etching something like paper, you're going to cut through it no matter what you do. Some things just don't etch well, the laser's too powerful even on its lowest settings. Some things don't etch well because the laser's not powerful enough. It's, again, you just have to experiment. Remember to start with low power and work your way up. Always have some spare material.
Water, air, fan.
Yep. So, before you cut, as always, fan, water, air, make sure they're all actually running. You can usually tell by sound once you've done it a couple times, but make sure you actually do check that the air is flowing the first time. Then you'll see that it's set to just raster mode. If you've already set up raster and vector, you can set it to both, but I'm just going to use raster mode. I'll increase the resolution of it so we can actually see what's going on this one. Increasing it to 1000 dpi means that it will do 1000 passes per inch. Keeping it at 500 means only 500 passes per inch. You're basically doubling the amount of time it will take to do a raster by increasing the DPI, so weigh how much a good image is worth compared to how much time it takes to cut. So again, triple check the job perimeter. Water, air, and fan are on, and then you can hit go or the play button, and you'll see it's just jumping back and forth and only cutting where the logo is. One thing you'll notice is that we're cutting through the paper. A lot of times when you raster on acrylic, it's easier to remove the paper first so you don't have 1,000 little pieces stuck in all the letters. I probably should have done that, but didn't, so here we are.
I was about to ask,
Yeah.
are we supposed to leave the paper on?
You can leave the paper on. One thing I like to do is take the top of the paper off and leave the bottom on so you can see that it's getting all the way through with the white flash. You don't get the white flash when you're in the acrylic, only when it's cutting the paper. So you can see it's only cutting where the black was in the raster view. It will be not firing unless it's there. While this is cutting, you can look here in the bottom corner of the window. There's an estimated raster. As soon as you hit the go button, it will give you a rough guess on how long the cut will take. It's usually fairly accurate. That's the time we use when we're logging it in here on the clipboard that doesn't like to come off the hook. So you want to write down how many minutes a cut takes. The two squares I cut were less than a second each. This one is about 1.5 minutes. It's a good idea to round up. We're not charging a ton for laser usage. So you'll see it dinged and the raster is done, and you can clearly see the 801 Labs logo was etched into the acrylic. If I come in here and peel off some of this paper, you can see it's kind of a frosty white color compared to the otherwise clear acrylic. And you can also see that you'll need to get an X-Acto knife or some tweezers to take all the paper bits out of the tiny holes. So remember to remove your paper, unlike me. Kill the noise again. Let's see. Yep, we got raster settings. Oh, a handy thing you can do with your media files is if you want to cut and raster something, instead of trying to do it all in one PDF, you can make multiple PDFs that have registration marks on the outside corners. So, for instance, you've got this rectangle here that could be one PDF, and then you have your picture that's the same size as a second PDF. So that way you can do one file will cut the rectangle out, and the next file will engrave it, or do it in the opposite order. So it'll raster first and then cut it out. Because if you cut it out, you may misalign some pieces. Registration mark can be helpful, again, if your drawing program, like I use AutoCAD a lot, lots of people like Adobe Illustrator or Inkscape for vector. If it has multiple layers and you print directly to PDF, the PDF should preserve those layers when you print to Retina Engrave. I've found Retina Engrave can be buggy if you try to print directly from Inkscape on this computer particularly, so PDF is a good intermediary that seems to work reliably. I highly recommend PDFs, but you're free to experiment as long as you don't break the laser. Let's see. When you're done, you're going to have a lot of tiny pieces left behind. Make sure you actually pick them out of there. We've got a garbage bucket in here that you can throw the tiny pieces into, just so we don't have 1,000 tiny pieces of acrylic floating around. Let's see. It's also a good idea if you've been cutting a lot to leave the fans running for a minute before you open the door, so everybody else doesn't have to smell the melted acrylic as much. Yeah, double check the lens when you're done. If you've been cutting a lot of wood, it may be smokier, so you'll want to clean it when you're finished for the next user. And if it's really cold outside, leave the water pump running at night so the water in the laser doesn't freeze and shatter it. Let's see, when you're done, close all your files and log off of the shared computer. And I think that pretty much covers basics. Did I miss anything?
Not that I remember.
Okay.
So good questions now,
yeah.
I guess.
And again, we've got all of this is written down on a giant sheet, both attached to the laser and on the desk at the laser. It's essentially your mouse pad, so it should be pretty hard to miss. You've also got the materials list on the wall in the front if you're not sure what to use, and you've got a reference chart of everyone else who has cut something, how long it took, and at what speed they were using it. So, yep. That's the gist of it. Hopefully I wasn't a total ass and you now know how to use a laser.
What speed did you engrave that on?
That was 50% speed and 100% power. And if I had lowered the power, it probably wouldn't have made it all the way through the paper. If I had upped the speed more, it might not have made it all the way through the paper.
You said that was 50% speed?
Yeah.
So if you cut it to like 25%, it would etch it a little.
Yeah, if you cut it at
deeper.
25%, it would etch it much deeper.
And
If you
take the
cut it
paper,
at
the paper cuts down on the depth that it cuts.
yeah, and if you cut it at 17% speed, you might be cutting all the way through. So it's all trade-offs. The raster's typically a bit faster than the vector cut speed, so you may not get all the way through at 17, but I bet if you were at 5% speed, you would be cutting all the way through on
just
the
thinking
raster.
As far as numbers, to cut a little deeper to make it etch a little.
Yeah, and different materials react to the laser in different ways, so again, there's a lot of experimenting. Any other questions? Okay. Congratulations, you've learned lasers.